Chemists like to work with highly purified substances, and one of the most pure substances are crystals. In this screencast, we'll describe how to make them, the stepwise process of recrystallization. It's a time-honored method that works very well for making pure substances. And understanding this process involves knowing certain things. For example, the principle behind recrystallization can be called restacking. We'll be able to understand why that's the case. It's a good visual understanding. The most common error during recrystallization is a failure to make a supersaturated solution. That's one of the key elements of recrystallization. When that happens, something goes very wrong, and we'll talk about what that is. And the terms supersaturation and nucleation relate to each other very closely, and we'll talk about how they relate. Okay, here's how to make crystals. This is screencast 11.4. It's a four-step process. First, you take an impure crystal or a solid like this one here, and then you supersaturate it. That means you heat it with a minimum of solvent. So there it is, it's dissolved. Notice this stuff does not look very pure. So it's got a huge amount of solute, dissolved material in there, more than it can really handle. And then the third step is we let it cool, or perhaps evaporate it, remove some of the solvent. Or even if you want to, you can apply a vacuum or a seed crystal. Either way, you can get that crystal to come out. Since it's supersaturated, it has to come out one way or another. After all, there's more dissolved material in there than it can normally handle. Finally, all you have to do is collect it. This is a vacuum filtration apparatus. It's perhaps the best way to do it. It simply filters the material very rapidly by applying a vacuum. So you throw your stuff in there and it gets sucked through and the solid stays there, and you end up with your recrystallized product. Here's a molecular view to help you understand it. Notice that this stuff is crystalline, but it has some occluded stuff. So I use that blue circle to show that crystal lattice has some impurities in it. Once it gets dissolved, that crystal lattice breaks up, and so that impurity separates out. To get this stuff to separate that stuff, you recrystallize it. These things tend to stack, and so as it stacks, it can remove, hopefully, those impurities, and that's the big principle behind it. It's a restacking process. Remove that stuff because it's dissolved, hopefully, and you have yourself a recrystallized material that can look extremely pure. Some vocab. If this stuff isn't even shiny, we call it an amorphous, meaning an impure solid without any shape at all. If it's crystalline, that means it's a shiny solid, and normally it's pretty pure. This one, probably not so much. Supersaturation is the principle behind recrystallization, and it's a case where the solution is oversaturated. It needs to come out of solution, but something needs to happen for that solute to pop out. When that first crystal forms, it's known as nucleation. This can occur sometimes homogeneously, where it just spontaneously pops out. That first crystal forms. If you can't wait forever, you can heterogeneously nucleate it. Usually that means add a crystal of the same material to get the process going. But there's other ways to do heterogeneous nucleation as well. And finally, to collect the stuff, the best method is to rapidly filter it using a vacuum shown here. This is screencast 11.4.